Hi guys, welcome. We're looking at day 9. We're going to be going over lesson 49 and 50 today. All right, so lesson 49, it was solving rate problems with proportions and equations. So we know what a rate is if we're talking about miles per hour, how far we can go miles per gallon, hourly wage for how much we get paid on the job, dollars per hour, whatever it is. So we have those rates. So these ratios are equivalent. Each reduces to 50 over 1. So 50 miles an hour over 2 hours, it'd be 100 miles. 3 hours, 154 would be 200 miles. These form a proportion. Thus, we may solve rate problems two ways, with proportions or by multiplying by the unit rate. So we'll look at both ways to do that. So these two methods are based on two forms of the rate equation. The ratio is constant, y over x equals k, or y equals kx. So k, it's bolded right there. K is our constant of proportionality. So it's our constant that isn't changing no matter what. So if we're talking about speed that we're traveling, how long we've been driving will affect the distance we've gone, but the speed at which we're driving isn't changing. We know when we actually drive, it fluctuates a little, but for the purposes of calculation, that k is always the same. So if we look at example 1, okay, if 6 books weigh 15 pounds, how much would 20 books weigh? So we can set it up in our ratios, 6 over 15, books and weight. Okay, and then we want to know how many 20 books weigh. Well, 20 over P for pounds, or we use X or Y or whatever we wanted to. Then we set up a 6 over 15, and then the 20 needs to be in the same numerator because 6 was 20 over P. We cross multiply. A 6P equals 15 times 20, which is 300. Okay, and then we divide. So cross multiply and divide. Then we divide both sides by 6, and we get 50 pounds because 300 divided by 6 is 50. So we can use that, set up our ratios. Since we know the books, they're all the same books, so they're going to weigh the exact same amount. It's not like one is 3 pounds and the next one is 7 pounds or something like that. They're going to be the same. So we can use that to calculate 20 books, 30 books, 40, however many we wanted. We could also figure out what's the weight per book and then multiply by 20 as well. We could do that if we want. Okay, if 6 books weigh 15 pounds, what is the unit rate? What is the weight of 20 books? Write an equation that shows how to find the weight, W, of books, knowing the number N of books at the unit rate. So 15 divided by 6, because it's 15 pounds over 6 books, it's 2.5 pounds per book. So that's the weight per book. And so that's our unit rate. Okay? That's not going to change. That's going to be constant. That weight per book is going to be constant. So then we can multiply the 2.5 by 20 to figure out, well, how much is 20 books going to weigh? 2.5 by 20 is still 50 pounds. So the equation we could use for any number of books would be W, our weight, equals 2.5, because that's our constant, that's our K, times the number of books. Once we know the number of books, which is our independent or our input, then we can multiply it by 2.5 and get our output, or our W, weight. 2.5 times 10, the weight would be 25 pounds. Okay, so we can plug in any number for N and calculate W. Let's look at example 5. 3 tickets cost $20.25. How much would 7 tickets cost? What is the unit cost? So 2025. So what is the cost for 7 tickets? We can set this up. Call it P for price is what we're trying to figure out. So we can do 20.25. Let me make sure I have the right number. Yeah, 20. So 20.25 over 3 equals a price. How much is it going to cost for 7? Cross multiply. I get 3P equals 20.25 times 7, which is 141.75. So I cross multiply, then divide. I always divide by this coefficient, so I get our unknown by itself. 141.75 divided by 3 is 47.25. 47.25. Now, if we wanted to figure out what were we asked to, what is the unit cost? Okay, let's clear this out of there. So price per 1 ticket, well, we know the cost for 3 tickets. We now know the cost for 7 tickets. So let's do 20.25, $20.25 divided by 3 equals $6.75. So that's the price per ticket. So each ticket costs $6.75. So we could say price equals our constant. That ticket price isn't going to change. 6.75 times the number of tickets. Okay, and then if we did 6.75 times 7, the number of tickets, let's see if we come up with the same thing. We should, yeah. So 6.75, we put in 7 for T. That times 7, it's going to equal $47.25. So 2 different ways we can go about getting the same solution. Okay, once we have a formula or a function or a rule for it, it's going to be a little bit easier to just plug in a number and solve. We can always use this method. Nothing wrong with it. It's just if we have a function or a rule, we could graph it. We could find any point on there. We could just plug in an input and quickly get our output. Okay, practice set we'll do together when we meet up. Okay, and then lesson 50, it's going to be the last lesson before our next unit test that we take. So we'll have plenty of class time to go over the review like we always do. But for lesson 50, we're solving multi-step equations. So we've looked at ones where we have 1 step, but we'll have more than that right here. So okay, if we look at this, okay, we have 2 steps that we have to take. We have to first, so let's look at it. It says, suppose a taxi charges $1.20 to start a ride, plus $3 per mile. If a ride costs $5.40, how far was the ride? X represents the distance traveled in miles. Solve the equation. So 3x plus 1.20 equals 5.40. So when we're solving for an unknown or solving for a variable, we think inverse operations. So I'm adding $1.20 or 1.20. So I need to subtract 1.20 from both sides. Okay, so inverse of addition is subtraction. 1.20 minus 1.20 is just 0. So that's how I'm able to get rid of it. Okay, I do the same thing to both sides. Okay, so I'm left with 3x or 3 times x equals 4.20. Then I divide both sides by 3, and I'm left with 1x or just x, and then 4.20 divided by 3 is 1.4. Okay, so we end up going, we do all the steps, the inverse operations to get x by itself, and we get 1.4, so that tells us we traveled 1.4 miles. And yeah, we'll do both of these, that's fine. Okay, so we have negative 2x minus 5 equals 9. Okay, so negative 2x minus 5 equals 9. So again, we have multiple steps that we have to take to get x by itself. We used to have just 2x equals 10. What does x equal? Or x plus 5 equals 8. What does x equal? Now we have multiple steps. We'll get down the road where, as you get into high school and things like that, where you have to take 10, 20 steps. You might use a whole sheet of paper, half a sheet of paper just to isolate a variable. So we don't have a ton of different steps for these ones that we need to take. And it's still the same process. We just think inverse operations and just work one step or two steps or three steps, 4 steps until we kind of get narrowed down to where x or whatever our unknown is isolated and by itself. So looking at this, to get rid of this negative 5, minus 5, I add 5. And I always rewrite it as I go. I know it takes up a little bit more room, takes a little bit more time, but then if you lose a step or you think your answer isn't right, you can just work back from the bottom up to the top to check your work. If you're doing it all mentally, then you're kind of, one, not doing best practice, and two, going to be out of luck if you need to check your work. So 9 plus 5, now I have negative 2x, so I divide by negative 2, that's my coefficient. Then a positive divided by a negative is a negative. Okay. Again, just think inverse operations. If I do something to one side of the equal sign, I have to do it to the other side, and then just keep working until you get x or whatever it is by itself. And then they're shown down below here, as I always mention it, especially on a test, plug it back in to make sure that it works out to be true. So negative 7 equals x, we'll plug it back in for x. Negative 2 times negative 7 is positive 14, minus 5 does equal 9. 9 equals 9, so the left side equals the right side. We know we did it correctly. Now this one we have to collect like terms. So we have 3x plus 4 minus x equals 28. 3x 4 minus x equals 28. Okay, so first thing we want to simplify both sides of the equation. Can't simplify this, but we can simplify this side of the equation. Since I have 3x minus x right here, okay, I can't add 3x and 4 or 4 minus x because I don't know what x is. But since these are the same terms, x and x, okay, if it was x squared, then I couldn't add it or subtract it. But since it's just x and x, I can combine these like terms. So 3x minus x, or we could write in the coefficient. We normally don't, but if we want to write in a 1, okay, we want to write in, where to go, minus 1x, we can do that. We don't normally do it because, again, we don't have to. But if you want to see that it's 3 minus 1, you can do that. If I have 3 of something, I take 1 away, I'm left with 2. So it's 2x, still plus 4, equals 28. So now it's simplified as far as I can get it on the left and the right side. So now I go inverse operations. Positive 4, so I subtract 4. 28 minus 4 is 24, so I'm left with 2x equals 24. Divide both sides by 2, and I'm left with 12. Okay. Then again, you could punch it back in, check your work to make sure it was correct. Okay. Practice that problem. We'll go over those in class. The investigation we may get to, we will see. Okay. That is all we have for today, and we'll see you guys soon.